Good morning, chemistry students. This is Mrs. Crumstarter with your corrections for ChemQuest 36. And again, remember that I asked you to balance every equation, so hopefully you did that. So we're going to start by talking about double replacement reactions. Remember on the other ChemQuest you saw single replacement reactions. So in the previous ChemQuest you learned about single replacement reactions in which a single atom replaces an ion from another reactant. Okay, so remember what they were telling you here was, remember single replacements, you had an element reacting with a compound, and your products were an element plus a compound. It was a different element and compound because the element kind of took the place of whatever it was like in that compound. And whatever you kind of displaced became all by itself as an element. Study what happens in the following reactions. They are called double replacement reactions. So we have magnesium chloride reacting with sodium fluoride to produce sodium chloride plus magnesium fluoride. Aluminum sulfide reacts with sodium oxide to produce aluminum oxide and sodium sulfide. Calcium nitrate reacts with sodium phosphide to produce sodium nitrate and calcium phosphide. Now, I do want you to balance everything, so we'll even balance these because you've already talked in class about how to balance chemical equations. So, 1 magnesium, 2 chlorines, 1 chlorine, so we need a coefficient of 2 in front of sodium chloride. 2 sodiums, 1 sodium, so we need a coefficient of 2 in front of sodium fluoride. 2 sodiums, 2 fluorines, so now it's balanced. 2 aluminums, that's good. 3 sulfurs, 1 sulfur, so we need a coefficient of 3 in front of sodium sulfide. So now I have 3 times 2, which makes 6 sodiums here, and I have 2, so I need a coefficient of 3 in front of sodium oxide. So now I have 3 oxygens and 3 oxygens, so that is balanced. 1 calcium, 3 calcium, so I need a coefficient of 3 in front of calcium nitrate. So now I have 3 times 2, which makes 6 nitrates, and I have 1 nitrate, so I need a coefficient of 6 in front of sodium nitrate. 6 sodiums, I have 3 sodiums, so I need a coefficient of 2 in front of sodium phosphide. And now I have 2 phosphorus and 2 phosphorus, so it's balanced. Now again, what we want to look at here as we see question number 1 is, what is the difference between single replacement reactions and double replacement reactions? Right, so we already kind of said about the single replacement. In the single replacement, we have an element reacting with a compound to produce an element and a compound, a different element and compound, but an element and compound nonetheless. And this element takes the place of whatever it's like in this compound, and then that element that is displaced is all by itself and becomes an element. Notice in our double replacement, we do have 2 reactants each time, and we do have 2 products each time. Notice our reactants every time are 2 compounds. Notice our products every time are 2 compounds. So for a double replacement reaction, we have 2 compounds as our reactants, producing 2 compounds as our product. Again, they're different ones, so what's happening here is we have a compound and a compound, and basically you can kind of look at it as the metals swap partners. And so you produce different products. So based on kind of that information, number 2 asks us to complete the following reactions by providing the formulas for the missing compounds. So again, we have copper and copper. We have nitrate and nitrate. So what we're missing here is our sodium and our chlorine. So that's going to be the product sodium chloride because it's an ionic compound. It's a metal and a nonmetal. So remember, we're going to do symbols, charges, crisscross, lowest whole number ratio. So here's our symbol for sodium. It has a charge of +1 because it's in group 1A. Chloride is -1 because it's in group 7A, and so I'd crisscross down those ones and I don't have to do anything. Now, again, because I've asked you to balance this, right? So 1 copper, 2 nitrates, and 1 nitrate, so I need a coefficient of 2 in front of sodium nitrate. 2 sodiums, 1 sodium, so I need a coefficient of 2 in front of sodium chloride. 2 chlorines, so it's now balanced. So we have zinc, we have iodine, so we're missing the aluminum and the sulfate. Remember when we write the formulas for ionic compounds, we always write our positively charged ion or our cation first. So in terms of names, right, this is going to be aluminum sulfate. It's an ionic compound because it has a polyatomic ion in it. So our symbol is Al. Aluminum's charge is +3 because it's in group 3A. Sulfate is SO4, and you have it memorized with a 2 negative charge. I have to crisscross down, so I have Al2. I'm going to have to put sulfate in parentheses and put my 3. If you're struggling with writing chemical formulas, please come and see me individually, and we can work on that. So 1 zinc, 2 iodines, and 3 iodines. So the number I can make them both is 6. To get 6 here, I need a coefficient of 2 in front of aluminum iodide. To get 6 here, I need a coefficient of 3 in front of zinc iodide, which means my zinc has changed. So I now have 3 zinc, so I need a coefficient of 3 in front of zinc sulfate. So 3 zinc, 3 times 2 makes 6 iodide, 2 times 3 makes 6 iodide. I have 2 aluminums here, 2 aluminums, 3 sulfates, so that is balanced. Next we have potassium, oxide, and magnesium bromide. Now, potassium and magnesium are both the positively charged ions, the cations, so they're going to swap partners. So they're going to be ionic compounds. So potassium's partner is now going to be bromide, and magnesium's partner is going to be oxide, and we always write our positively charged ion first. These are both ionic compounds, so I'm going to do symbols, charges, crisscross, lowest whole number ratio. Potassium is K with a +1 charge because it's in group 1A. Bromide is -1 with because it's in group 7A. Nothing to crisscross down there. Magnesium is Mg, charge of +2 because it's in group 2A. Oxide O, -2 because it's in group 6A. Again, I could crisscross down those 2's, but then I'd have to reduce it anyway, so I'm just not going to crisscross them down. So now I'm ready to balance this. 2 potassiums, 1 potassium. I need a coefficient of 2 in front of potassium bromide. 1 oxygen, 1 oxygen. 1 magnesium, 1 magnesium. 2 bromides, 2 bromides. It is now balanced. The next one, it looks like maybe that would be hard, but it's still the same thing. How this happened was these positively charged ions swap partners. So barium's partner was chloride, and sodium's partner was sulfate. So those are both ionic compounds because they contain metals. So again, I'm going to do symbols, charges, crisscross, lowest whole number ratio. Barium is Ba, charge of +2 because it's in group 2A. Chloride, -1, group 7A. I do have to crisscross down here, so I have BaCl2. Sodium is Na, +1. Sulfate is SO4, -2, so I do need to crisscross down, so I end up with Na2SO4. Now that I have my formulas written correctly, now it's time to balance. And remember, once we have our formulas correct, we don't change our subscripts. Our only way to balance is to use our coefficients out in front. So 1 barium, 2 chlorines, 1 chlorine, so I need a coefficient of 2 in front of sodium chloride. 2 sodiums, 1 sulfate, this is balanced. This last one, right? It's positively charged ions. So ammonia, remember, is the polyatomic ion you have memorized that has a positive charge. So it's going to switch partners with calcium. So ammoniums partner is going to be iodide, and calcium's partner is going to be carbonate, because they've just switched partners. These are both these compounds contain a polyatomic ion, which makes them an ionic compound. So again, we're going to do symbols, charges, crisscross, lowest whole number ratio. Ammonium is NH4 with a +1 charge that you have memorized. Iodine's I with a -1 charge, so nothing to do there because we crisscross down once. Calcium Ca +2, and carbonate you have memorized as CO3 -2. So again, I could crisscross down those 2's, but then I would reduce them, so I'm just not going to do it. So balancing now, 2 ammoniums, 1 ammonium, I need a coefficient of 2 in front of ammonium iodide. 1 carbonate, 1 carbonate, 1 calcium, 1 calcium, 2 iodines, 2 iodines, so it is balanced. Number 3 asks you, name the 2 products of the reaction between calcium phosphate and sodium iodide. And again, the easy thing to kind of do there, right, is that they just swap partners. So sodium's partner is going to be phosphate, and calcium's partner is going to be iodide. So again, just think of double replacement reactions as the positively charged ions swap partners. So, our next page, explain why when you mix the following reactants, no reaction occurs. Well, my positively charged ions swap partners, right, which is sodium and sodium. When they switch, my products are going to be Na +1 SO4 -2 and Na plus Cl minus, right? Because both of the positively charged ions are sodium, really there's no reaction that takes place here. So the person who wrote this ChemQuest explained it this way. They said both reactants contain sodium. Therefore, if the sodium atoms replaced each other, the same products would be formed. No change would occur, okay? So there's really no reaction happening here. All right, so far we've seen there are 5 different types of chemical reactions. So far you've seen single replacement and double replacement. Here's our next type, combustion reactions. Another type of reaction is a combustion reaction. During combustion, a hydrocarbon reacts with oxygen. The products for complete combustion are always the same, water and carbon dioxide. And energy. The following equation is an example of the combustion of a hydrocarbon. So this is the hydrocarbon. We always have to have oxygen because, remember, we're burning something. Combust means to burn. And one of the ways that you can put out a fire is to smother it, to deprive it of oxygen. So you always need oxygen as another reactant in a combustion reaction. And the products are always carbon dioxide and water. Now, balancing this, 3 carbon, so we put a coefficient of 3 in front of carbon dioxide. 8 hydrogen, so we need a coefficient of 4 in front of water. So here we have 6 oxygens, and here we have 4. So that's 10 oxygens altogether. So to get 10 oxygens on my reactant side, I need a coefficient of 5 in front of oxygen. Number 5 asks us to complete the following reactions by supplying the missing compound in each blank. Again, for a combustion reaction, what's missing here is the oxygen. And it's always O2 because remember, it's part of our Hoff-Brinkel or our Brinkel-Hoff, and it always has to be diatomic. Now, balancing this, 4 carbon, so I need a coefficient of 4 in front of carbon dioxide. 8 hydrogen, so I need a coefficient of 4 in front of water. So I have 4 times 2, 8, and 4 more here, which makes 12. So I need a coefficient of 6 in front of oxygen. Our next one, we have our products are missing. And remember, our products are always the same. They're always carbon dioxide and water. So balancing this, we have 6 carbon, so we need a coefficient of 6 in front of carbon dioxide. 14 hydrogen, so we need a coefficient of 7 in front of water. Now, oxygen oftentimes is the hardest to balance. So here we have 6 times 2, which is 12, plus 7, which is 19. And we can't get an odd number with a 2. So here's a trick, and we're going to talk about this in our notes too. We're going to take that odd number we need and put it over 2. Now, we can't have a coefficient that's a fraction. So how do we get rid of that 2? We're going to take every coefficient in the equation and multiply it by 2. So this coefficient is currently a 1. I multiply it by 2 and it becomes a 2. This 19 over 2, when I multiply it by 2, it's going to become 19. The 6 is going to get multiplied by 2 and become 12. And this is why you use a pencil to do this. And 7 multiplied by 2 becomes 14. So, checking this that it's balanced, 6 times 2 is 12 carbons, 12 carbons. 2 times 14 is 28 hydrogens, 14 times 2 is 28 hydrogens. So here I have 24 oxygens, 12 times 2, and here I have 14 more, which gives me 38. And 19 times 2 is 38, so this is now properly balanced. Number 6. Write a combustion reaction for C5H10. So again, this is my hydrocarbon. My other reactant has to be oxygen for it to combust or for it to burn. And my products are always carbon dioxide and water. Balancing this, 5 carbons, so a coefficient of 5. 10 hydrogens, coefficient of 5. I have 10 and 5 is 15. So I'm going to do that 15 over 2. And then I'm going to come through and multiply. So a coefficient of 2. 15 over 2 is going to become 15. 5 is going to become 10 because I multiply it by 2. And this 5 is going to get multiplied by 2 and become 10 as well. So 2 times 5 is 10, 10 carbons. 2 times 10 is 20, 10 times 2 is 20. Here I have 10 times 2, which is 20, and here I have 10 more. So that makes 30, and 15 times 2 is 30. So that's our third type of reaction. So far again we have single replacement, double replacement, and combustion. Here are our last two types of reactions. Synthesis and decomposition reactions. Two other types of reactions are synthesis and decomposition. Your textbook, by the way, calls this a combination reaction. Okay. During a synthesis reaction, several reactants combine to make a single product. During a decomposition, one reactant decomposes into 2 or more products. The following table shows some examples of these types of reactions. So here we have some synthesis reactions, and over here we have decomposition. Again, what we want to kind of notice here is, what do the synthesis have in common? Notice we have 2 reactants and 1 product. And over here for the decomposition, notice we have 1 reactant, and we're just going to kind of say 2 or more products. Now, balancing these, right? 2 hydrogens, 2 hydrogens, 2 oxygens, so I need a coefficient of 2 in front of water, which means I need a coefficient of 2 in front of hydrogen. 1 sodium, 2 chlorine, so I need a coefficient of 2 in front of sodium chloride, so I need a coefficient of 2 in front of sodium. Over here, H2O, right, it's pretty much going to be the same. I have to put a coefficient of 2 in front of water so that I have 2 oxygens and a coefficient of 2 in front of hydrogen. Sodium chloride, again, I need a coefficient of 2 to balance my chlorine, and then a coefficient of 2 in front of sodium. Every synthesis reaction has, okay, 1 product, and every decomposition reaction has 1 reactant. Okay, so we already kind of looked at that. All right, write a synthesis reaction for sodium metal reacting with chlorine gas to form sodium chloride. Remember that chlorine is diatomic. Again, I like to do what I've taught you to do, so I like to take this sentence and make it a word equation. So basically I have sodium, right? The metal is extra information. Reacting with is a plus. Chlorine, the gas again, is extra information that I really don't need. To form is my arrow, and then sodium chloride is my product. right? It gets rid of extra information I don't need. So now I just write the symbols for all of these, right? So sodium is Na. Chlorine is Cl2 because it is diatomic. This is an ionic compound, so I'm going to do symbols, charges, crisscross, lowest whole number ratio. So Na plus Cl minus, so nothing to do. Balancing this then, again, we're going to put a coefficient of 2 in front of sodium chloride and a coefficient of 2 in front of sodium. Number 9, categorize each of the following reactions as single replacement, double replacement, synthesis, decomposition, or combustion. So this one here, notice we only have one product, and the only kind of reaction where I have a single product, okay, is a synthesis reaction. So this is going to be an S. Now let's go ahead and balance this. I have 1 calcium, 2 oxygen, and I need a coefficient of 2 in front of calcium oxide, which means I need a coefficient of 2 in front of calcium. Letter B is over here. So notice here, I have 2 reactants and 2 products. So that means it could be combustion, but it's not combustion, there's no hydrocarbon. It could be double replacement or single replacement. So how do I decide which one it is? Notice I have a compound and an element. And the one that has an element in it is a single replacement reaction. Balancing this, 1 magnesium, 1 magnesium, 2 nitrates, we only have 1 nitrate, so we need a coefficient of 2 in front of copper nitrate, and now we need a coefficient of 2 in front of copper. All right, here we have a hydrocarbon reacting with oxygen to produce carbon dioxide and water, right? That's a combustion reaction. To balance this, 4 carbons, so we need a coefficient of 4. 10 hydrogen, so I need a coefficient of 5. So I have 8 plus 5 is 13. So I'm going to end up with 13 over 2, right? And I multiply by 2, so I get that 2 there. I get rid of that 2. My 4 is going to become an 8. My 5 is going to become a 10. And checking that, 8 carbon, 2 times 10 is 20. 10 times 2 is 20. 26 oxygen. I have 8 times 2, which is 16, plus 10 more, which is 26. Over here, right, what type of reaction? I have a single reactant, and there's only one kind of reaction that only has one reactant, and that's your decomposition. So this is a decomposition reaction. 2 aluminum, so I need a coefficient of 2 in front of aluminum. 3 oxygens and 2 oxygens, so my only number I can make them is 6. So that means I need a coefficient of 2, which means I need to change my 2 in front of aluminum to a 4. Again, good reason to use a pencil. Letter E, type of reaction, right? I have 2 reactants, 2 products. So again, it can be combustion, single replacement, or double replacement. It's not combustion because it doesn't have a hydrocarbon. So is it single or is it double? Again, I have a compound reacting with an element. That makes it a single replacement reaction. Balancing this, 1 strontium, 1 strontium, 2 chlorines, 2 chlorines, 2 fluorine, 2 fluorine. This is one of those skeleton equations that's also a balanced equation. Next we have, again, 2 reactants and 2 products. So again, it could be combustion, it could be single replacement or double replacement. It's not combustion, there's not a hydrocarbon. So it's either single or double. This one, both reactants are compounds, which makes this a double replacement reaction. So we have 1 barium, 2 fluorines, 1 fluorine, so we need a coefficient of 2 in front of sodium fluoride, 2 sodiums, 2 sodiums, 1 oxygen, so it is now balanced. Number 10, write an equation for the combustion of C3H6. So C3H6, that's my hydrocarbon. Because it's combustion, remember the other reactant I need is oxygen, and my products are always carbon dioxide and water. Balancing this, I need a coefficient of 3 in front of carbon dioxide. I need a coefficient of 3 in front of water to get 6 hydrogens. So now I have 3 times 2, which is 6, plus 3 more is 9. So I'm going to do that 9 over 2, that odd number I need, and then multiply through by 2. So this is going to become a 2. My 9 over 2 is going to become a 9. My 3 is going to become a 6. And this 3 is going to become a 6. I'm going to check it. 2 times 3 is 6. 6. 2 times 6 is 12. 6 times 2 is 12. 18. So 6 times 2 is 12, plus 6 more makes 18. Write the equation for the decomposition of calcium oxide. So calcium oxide, that's an ionic compound. So my symbol is Ca. My other symbol's O, -2, +2, so nothing to do. Now, what's the only thing this can decompose into? It's elements. So it's going to decompose into calcium and oxygen. Just remember that oxygen is diatomic, so it has to be O2. Balancing this, 1 calcium, 1 oxygen, 2, so I need a coefficient of 2 in front of calcium oxide and a coefficient of 2 in front of calcium. All right, some practice problems. Complete the following reactions. So the first thing to predicting the products, which is something you're going to have to do, is to identify what kind of reaction this is. So I have 2 reactants, so it's either single replacement, double replacement, combustion, or synthesis. Well, that doesn't look like a synthesis. In synthesis, you won't very often be asked to predict the products of. It's not a combustion reaction because it's not a hydrocarbon, so it's either single or double replacement. And again, notice this is a double replacement because it's 2 compounds. So remember, my positively charged ions, which are sodium and aluminum because they're both the metals, are going to swap partners. So sodium's partner is now going to be nitride, and aluminum's partner is going to be carbonate. So now these are both ionic compounds. So I just symbols, charges, crisscross, lowest whole number ratio, Na plus, N -3, so Na3N plus Al plus 3. Carbonate is CO3 -2. I crisscross down. I'm going to need parentheses this time. Now balancing this, 2 sodiums, 3 sodiums, so I can make them both a 6. So I have 3 times 2 is 6, 2 times 3 is 6. 3 carbonates, I have 3 carbonates. 1 aluminum, I need 2 aluminum, so coefficient of 2. 2 nitrogens, 2 nitrogens, so it is balanced. Again, same thing with this one, right? 2 reactants, so again, it's not a synthesis because, again, typically you won't be asked to predict the products. It's not a combustion because it doesn't have a hydrocarbon. So it's either single replacement or double replacement. This one is single replacement because I have an element reacting with a compound. Now, I have to be careful here. Fluorine is a nonmetal, so it's going to take the place of chlorine in this product. So it's chlorine that's going to be by itself, and I'm going to have barium fluoride. Chlorine Cl2, barium fluoride, that's an ionic compound, so Ba plus 2F -1, I crisscross down. Balancing this, 1 barium, 2 chlorines, 2 chlorines, 2 fluorines, 2 fluorines, it is balanced. This next one, again, it has to be, right? My choices that have 2 reactants, right, are I can have a synthesis or a combination. I can have a single replacement, I can have a double replacement, or I can have a combustion. This one's not combustion because there's not a hydrocarbon. This one's not synthesis because you typically won't be asked to predict the products of synthesis. So it's either single replacement or double replacement. I have an element reacting with a compound, which makes the single replacement. Now, this element is a metal, so it's going to take the place of the metal. So, copper is going to be by itself, Cu, and again, this is an ionic compound. So, silver, and it's on your helper sheet, but it only has one possible charge of +1, and nitrate, NO3, -1. So, this is my skeleton equation. 1 copper, 1 copper, 1 nitrate, 1 nitrate, 1 silver, 1 silver. This is a skeleton equation that's also a balanced equation. Number 2, Fill in the blanks for the missing reactant or product, and then in the blank to the left of each equation, indicate whether the reaction is a single replacement, double replacement, synthesis, decomposition, or combustion. So here we're trying to figure out what's missing. So we have lithium, we have chlorine, so we're missing zinc and nitrate. And zinc is Zn, charge of +2, it's on your helper sheet, but only has one possible charge. NO3 is -1, so I need parentheses and a 2. Balancing this, 1 lithium, 1 chlorine, 2 chlorine, so I need a coefficient of 2 for the lithium chloride, which means I need a coefficient of 2 in front of lithium nitrate. 1 zinc, 2 nitrate, 2 nitrate. Now, notice I have 2 reactants, so it's one of these 4 types. It's not combustion, it's no hydrocarbon. It's not synthesis because there's 2 products. It's either single or double. Remember, it's double because it has 2 compounds reacting. Our next one, we have calcium, we have bromine, so we're missing sodium. Again, 2 reactants, so it has to be one of these types. It's not combustion, there's no hydrocarbon. It's not synthesis because I have multiple products, so it's either a single or double replacement. Again, here I have an element reacting with a compound, so this is a single replacement. Balancing this, I have 1 sodium, 1 calcium, 2 bromine, so I need a coefficient of 2 for the sodium bromide, which means I need a coefficient of 2 in front of sodium. Lastly, K plus Cl2, and notice they put a line here, which tells you there's only one product. So I have 2 reactants but 1 product, so 2 reactants. Combustion, right, would have more than 1 product. Double replacement has more than 1 product. Single replacement has more than 1 product. This has to be a synthesis. So my product must be potassium chloride. That's an ionic compound, so my symbol is K and Cl, +1 and -1 charge, so nothing to do to balance that, or to crisscross down. To balance it, 1 potassium, 2 chlorine, so I need a coefficient of 2 in front of potassium chloride, which means I need a coefficient of 2 in front of potassium. Again, if you're kind of feeling like you're a little overwhelmed, it's okay. We're going to talk about this in our notes and take notes over these 5 types of reactions. But this was just to get you started on it. Have a great day. Talk to you tomorrow.